Okay, look at this example 5.2c, two-way ANOVA. The effective life in hours of batteries is compared by material type 1 to 3. So we have here battery's life and we have the material type and operating temperature. Okay, medium, low and high. 12 batteries are randomly selected from each material type and then randomly recorded to the temperature level. The resulting life of all 36 batteries is shown below. So, soalan ni, this question want to test, is there any interaction effect between temperature and material type to the effective life of batteries? Adakah menggunakan temperature yang berbeza dan material type yang berbeza memberi kesan kepada penggunaan bateri itu? Okay, is it different temperature and different material type give effect to the effective life of batteries? Okay, is it different temperature and different material type give effect to the life of the batteries? Adakah menggunakan operating temperature yang berbeza dan material type yang berbeza akan memberi kesan terhadap berapa lama bateri itu boleh kekal? Okay, so there are three variables here. You have temperature, you have material type and have life of the battery. So the life of the batteries depends on the different temperature and different material. So from here, we can know that first, our independent variable is material type and temperature. So, as we mentioned, from the independent variable, we also can get factor A and factor B. So, our factor A is material type and our factor B is temperature. What is our dependent variable? Dependent variable will be life of batteries. Okay, so small a, number of factor A. Factor A is material type. How many material type we have? 3. So A is equals to 3. Material type 1, material type 2 and material type 3. Okay, and then B, number of factor B. Our factor B is temperature. How many temperature we have? Low, medium and high. So B is also equals to 3. So from here we can get treatment. K is equals to A times B. So 3 times 3 equals to 9. So you will have 9 treatments. What are the 9 treatments? So you will have material type 1. So material type 1, temperature low. Material type 1, temperature medium. Material type 1, temperature high. 3. Okay, material type 2, temperature low. Material type 2, medium. Material type 2, high. Material type 3, low. Material type 3, medium. Material type 3, high. So you get 1, 2, 3, 4, 5, 6, 7, 8, 9 treatment. Right. So if you look at the question, what are the factors involved in the study? I've answered this one. Factor A is material type. Factor B is temperature. How many treatments involved in this study? Treatment we have 9. List all the possible treatments. So these are the 9 possible treatment. Okay, this is how you want to answer the question. Right, so I'll leave it first for number 3. So I hope you can understand from the two-way ANOVA here, what is the independent variable? What is the factors? What is the dependent variable? What is factor number of factor A and factor B? How to calculate treatment and list all the possible treatments. Alright, now let's investigate the ANOVA table for two-way ANOVA. So the two-way ANOVA table is different from one-way ANOVA table. So what are the different? If you look at here, we have interaction. Interaction is the interaction between factor A and factor B. Sample here is for factor A, column here is for factor B. Within is error and total is total. SS is sum of square, DF is degree of freedom, MS is mean square, capital F here is F test, P value, and F critical value here is F alpha, nu1, nu2. If you notice, you have the additional row which is interaction. It shows that this ANOVA table is two-way ANOVA. Two-way ANOVA table will given to you in Excel output. So this is a two-way ANOVA in Excel output. The Excel output two-way ANOVA table will look like this. So now let's investigate how do we get all the values. Alright, from here, source of variation sample. Source of variation factor A will be given. Source of variation factor B also will be given. Here all the SS will be given. Now, how do we get degree of freedom factor A equals to 2? Okay, degree of freedom factor A equals to 2 we got from A minus 1. A is number of factor A. Our number of factor A material type is 3. So 3 minus 1 equals to 2. Then you will get 2 there. How do we get degree of freedom factor B equals to 2? So recall back, our temperature is 3, low, high and medium. So B minus 1, 3 minus 1 is 2. So that's why you get 2 here. How do we get degree of freedom interaction? Degree of freedom interaction is degree of freedom factor A times degree of freedom factor B. 2 times 2 you will get 4. So here 4. And then how do we get degree of freedom total? Degree of freedom total is total data and minus 1. We have total data 36 minus 1 is 35. So that's why you get 35 here. And lastly, how do you get degree of freedom error? Degree of freedom error equals to degree of freedom total minus degree of freedom factor A minus degree of freedom factor B minus degree of freedom interaction. So you will get 27. Right, so we go to the MS. MS. How do we get mean square? Mean square factor A. How do we get mean square factor A? Mean square factor A is equals to 10683.7222 divided by 2. You will get 5341.6811. Okay. For the MSB, how do we get that one? 39118.7222 divided by 2. You will get 19559.611. How do we get MS interaction? MS interaction is 9613.7778 divided by 4. You will get 2403.4444. And lastly, how do you get the MSE? MSE is equals to 18230.75 divided by 27. You will get 675.2130. And here, F test. Okay, F test. How do we get the F test? So the F test here. F test for factor A. So 5341.8611 divided by MS error 675.2130. 2130. You will get the F test this one. Okay, the same goes to the F test B. How do you get the F test B? F test B is equals to M 2403.4444 divided by 675.2130. You will get the F test factor B. And the same goes to the factor F test AB. F test interaction is equals to 2. This one is F test A, B. So F test B is equals to 19559.3611 divided by 675.2130. You will get the F test B. Okay, so P value is generated to you and F critical value is also generated to you. So you have to know where they got this value manually. Okay, I hope you can try on yourself, get the calculator and try to figure out how they got the value in the Excel output manually. Right? Okay, last question, for example 5.2c, question number 3. By using p-value approach, is there any interaction effect of different material type and operating temperature levels to the life of batteries? So the question asks us to test, is there any interaction effect? When we talk about interaction, it is a two-way ANOVA. Interaction effect between material type and operating temperature. So material type is factor B, material type is factor A, operating temperature is factor B. Okay, how to answer this question? As I said in the slide, we have to test the interaction first. We have to test the hypothesis for interaction first. So now test the interaction. Test the interaction, start with step number 1. H null and H1. So H null always no. So we put here, there is no interaction effect between material type and temperature. If H null no interaction, H1 there is an interaction effect between material type and temperature. Okay, this one is step number 1. What is step number 2? Step number 2 is the p-value. If you look at here, we have 3 p-value. So which p-value that we want to take first? Look at the p-value interaction. Okay, look at the p-value interaction first. So the p-value interaction is equals to 0.0186. 0.0186. Step number 3, compare. Our alpha is 0.05. Right. Since p-value 0.0186 is less than alpha 0.05, we have to reject H null. So step number 4, what happens if you reject H null? You reject this one. Is there any interaction? Yes. So the conclusion is at alpha 0.05, you copy back, there is an interaction effect between material type and operating temperature. So when you are using different material type and different operating temperature, give you different results of battery's life. So in two-way ANOVA, when you said that there is an interaction, the next step is you have this to stop the process. You don't have to find factor A and factor B.